everyone, I'm Riswana Perveen, Assistant Professor of Department of Mathematics from St.Josephs College. Today we are going to see about the Gauss-Jordan method. So what is Gauss-Jordan method? It's we have seen already a Gauss elimination method similar to that, the Gauss-Jordan method. Gauss-Jordan method is similar to Gauss elimination method, but like I'm gonna convert the simultaneous equation to an Ax is equal to b. But A matrix should be result. The A matrix should have a diagonal matrix to reduce. We have to reduce the A matrix to an diagonal matrix. Whereas in Gauss elimination method, it is reduced to an upper triangular matrix. Here I am going to reduce it to a diagonal matrix, which is like this. Like I want the values in the diagonal only. Rest all the parts should be of 0. So I want every part should be 0. But in a diagonal value, I want it to be a value. I want it to be have value. I don't care if B matrix doesn't have a diagonal matrix. It's not important, but A matrix should be diagonal matrix. So this can be the system of equation reduced to the following in equation, which is in the format of like this. So this from this I can get directly values. In this, I don't have to use a substitution equation over here, but you can get the result directly after solving the uh, problem. Like you can see over here from I want x value, right? So I can get x value like x1 equal to b1 divided by a11. That is first element. It goes on for all values. The method of obtaining the solution of the system of equation by reducing the matrix A to a diagonal matrix is known as Gauss-Jordan method. So this is a theorem on the Gauss-Jordan method. Now let us see a problem on Gauss-Jordan method. Like I have given over here is this question, and I similar like I want to convert this to an argumenting matrix. Like I want only the values over here, and then I'm applying the row operation rule over here. Like I R1, I want this first element to be 1, so it does satisfy. But in case of solving, I can like interchange row first element to be some element 1. Well, if I have 1 means I can solve so easy, so I'm going to interchange row 1 to and row 2. So like this, you can see that row 1 is interchanged with row 2, and then I'm applying again a rule so that here this part to be 0, like row 2 equal to row 2 minus 5 into r1. So 5 into r1 is nothing but 5 into 5, 7 5 star over 45, and 3 5 are 15. So you can apply then if r2 minus, that is 5 minus 5 is nothing but the 0, and I'm applying the formula over here. I'm going to do this process until I get zeros over here. You can note this out, or you can solve it in I solve in this method. Everyone, you can solve in any method so that you can get the result in a diagonal matrix. So I got over here as a 0 0 0, and I got the result in a diagonal matrix. From this I can get the direct values, like x is equal to 1, y equal to minus 2, z is equal to 3. Because other matrices are 0. Only in diagonal matrix are having the value. So final result will be 1. Final result will be x is equal to 1, y is equal to minus 3, and z is equal to 3. Thank you everyone for listening. I hope you understand.